when we install the Docker desktop come up with the Docker client and Docker daemon both. So we will have a Docker host and Docker client. So Docker host is basically, and Docker daemon, something we call as, is basically responsible for your build, run and so run the containers, correct? So your Docker client will connect to a Docker daemon, and Docker daemon will basically just manage, basically build the image. From the image you will create the containers, correct? So you can also push that image to your Docker registry. So once you build the image, something is a configuration file which is basically representing to a container. So you can also store the image. So basically Docker daemon will connect to any registry. So this registry can be a Docker Hub public registry, or maybe a GCR on Google Cloud, or maybe a Azure container registry, or maybe a Elastic container registry on AWS, correct, like this. So Docker daemon, basically Docker daemon listens to a Docker API request from the managed Docker objects such as the image, containers, networks and volumes, correct. So Docker daemon can also communicate with other daemons to manage the Docker service, correct. That is the overall role, is basically a Docker daemon. So Docker client is the primary way that manage the Docker users interact with the Docker, right? So when you use the commands such as a docker run, the client sends these commands to a Docker daemon, Docker D, which carries them out, okay. And the Docker command uses the Docker API, and Docker client can communicate with more than one daemons, like that. So this is basically overall about the Docker client. So you can run this command from the command prompt, and this from that you will communicate it basically to your Docker daemon, and then you will work it out. So Docker desktop is what you have installed here, is an easy to install application on your Mac or Windows environment that enables you to build and share the containerized application in microservices. So Docker desktop include the Docker daemon, right, Docker D, the Docker client, Docker compose, Docker contain trust, Kubernetes and credential help here. So these are the basically combined package inside the Docker desktop. So Docker desktop also have that single cluster Kubernetes also, you can get it. You will get it Docker compose, you will get a Docker client, and also Docker engine, Docker daemon also. So Docker registries store the Docker images. Docker Hub is a public registry that anyone can use it. Docker is configured to look for images on the Docker Hub by default. So by default Docker Hub is looking for that registry into a Docker Hub. If you wanted to change the registry, you can change it. You can tell to a system that you can look for my images into a different registry, correct. So when you use a Docker pull or Docker run commands, the required images are pulled from your configured registry, okay. Docker push command is used to push your images to your Docker registry, okay. Docker objects, when you use a Docker, you are creating using images, container, network, volumes, plugins and other objects. These are basically overall all about that your object. So images is, what is the images? So an image is a real read-only template which instructs for creating a Docker container. Very important point. You need to understand what is the image, right? So everything, you create the container from the image, right? So that is basically a read-only template. So often an image is based on the another image, that is also with some additional customization. So the image can also depends on another image also. For example, you built an image which is based on the Ubuntu image, but install the Apache web server. Your application as well as the configuration details needed to make your application run. So your image can be also dependent on other images. So first these images will be used, then your image will be getting. So that's why this entire ecosystem will be created from images to images, like that. So okay, like that. You might create your own image, or you might only use this created by others and publish into registry. So you can create your own and use your own image. Also you can use others images as well. To build your own image, you can also create a Docker file with a simple syntax to defining a step needed to create your image and run it. So this Docker file is basically help to you for create and run the image. For instruction in a Docker file creates a layer in the image. When you change the Docker file and rebuild the image, only those layers which have changed are rebuilt. It's very important point. Okay, this is a part where makes the image so lightweight, small and fast when compared to a virtualization